Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray and in this video we'll be looking at the even and odd functions. So let's get started. Okay, now even and odd functions. Let's start with the even function. The definition of an even function. A function is said to be even if the condition is that f of minus x is equal to f of x for all x in the domain. What this means is that if I replace x in the function by minus x everywhere and that function comes out to be equal to f of x itself, then it is known as an even function. Let's suppose take an example. Say the function is f of x is equal to x square. If I write f of minus x, this is equal to minus x whole square, which is again equal to x square, which is in fact equal to f of x itself. So in this case, f of minus x is equal to f of x. That's why this is an even function. Another property of an even function is that the graph of an even function is symmetric with respect to the y-axis. Let's take this function as itself. So if I take the graph of this function, it is a parabola facing upwards like this, vertex at origin. If we look at it, the graph is symmetric with respect to the y-axis. It is symmetric on these sides. We can see here that if x is equal to 2, y is equal to 4, and if x is equal to minus 2, it is equal to 4 itself also. So it is symmetric with respect to the y-axis. If I take one more example, let's say the function f of x is equal to cos x. Now f of minus x is equal to cos of minus x. We'll replace x by minus x everywhere in the function, and now we know that cos of a negative angle is equal to cos x itself, which is in fact equal to f of x. So in this case, f of minus x is equal to f of x, therefore it is an even function. Let's look at the graph. It should have this property. So the graph of cos x is something like this. And if you look here, this is the y-axis, and as the graph on this side, the same graph is being made on this side. That means there is a mirror image with respect to the y-axis. So it's symmetric with respect to the y-axis. This is the property of an even function. Now let's look at an odd function. Odd function. A function is said to be odd if f of minus x is equal to minus of f of x. If this condition is satisfied for all x belonging to domain, then it is an odd function. F of minus x means that if I replace x by minus x in the whole function, and this comes out to be equal to minus of f of x, then it is an odd function. For example, let's take f of x is equal to x cube. F of minus x will be equal to minus x whole cube, which is equal to minus 1 cube into x cube. Minus 1 cube will be equal to minus 1. So this is minus x cube, which is in fact equal to minus of f of x. So since this condition is satisfied, this function is an odd function. Now the property of an odd function is that the graph of an odd function is symmetric in opposite quadrants. It is symmetric in opposite quadrants. Opposite. Or we can also write it as symmetric with respect to the origin. Let's look at the graph here of this function. X cube graph is like this. It is a cubic polynomial function. The graph is like this. If we look at the graph, we can see that just the graph in the first quadrant is like this. Exactly symmetric, the graph is in the third quadrant as well. So this can be said that this is symmetric with respect to the origin. The graph is symmetric with respect to the origin. Let's look at one more example. Say f of x is equal to sine x. If I find f of minus x, that is equal to sine of minus x, which is equal to minus sine x, which is in fact equal to minus of f of x. Since this condition is satisfied, this is again an odd function. It should have this property that we talked about. So the graph of sine x, let's look at that. The graph of sine x is like this. And if we look at the graph, we can see that just as the graph is being made in the first quadrant, a mirror image is being made in the third quadrant with respect to this origin. So we can say that it is symmetric in opposite quadrants, or it is symmetric with respect to the origin. This is the property of an odd function. Okay, so let's sum it up. An odd function is a function if it satisfies the condition that f of minus x is equal to minus of f of x, and it has the property that the graph of this function is symmetric in opposite quadrants, or it is symmetric with respect to the origin. An even function is a function which satisfies the condition f of minus x is equal to f of x. For all values of x, and it has the property that the graph of an even function is symmetric with respect to the y-axis. That means we get a mirror image with respect to the y-axis for an even function. Okay, now let's look at a few examples. First example, f of x is equal to x to the power 4 plus x square. Tell whether it is an even function, an odd function, or neither of them. So we find f of minus x. F of minus x is equal to minus x to the power 4 plus minus x whole square. We will replace x by minus x everywhere. Minus x to the power 4 is x to the power 4. Minus x to the power 2 is x to the power 2. which is again equal to f of x. Since f of minus x is equal to f of x, this is an even function. Second example, g of x is equal to 2x cubed minus 5 by x. G of minus x is equal to 2 into minus x whole cube minus 5 upon minus x, which is in fact equal to minus 2 into x cube plus 5 by x, which is equal to minus of 2x cube minus 5 by x after taking one negative common, which is equal to minus of g of x. Since g of minus x is equal to minus of g of x, this is an odd function. Odd function. Next example, h of x is equal to minus 4x plus 3. H of minus x is equal to minus 4 into minus x plus 3, which is equal to 4x plus 3. Now 4x plus 3 is neither equal to h of x, neither is it equal to minus of h of x. Therefore, this function is neither odd nor even. And yes, that is possible. Okay guys, so we looked at even and odd functions in this video. If you want to keep watching videos like this, hit the like button and subscribe to our channel, and we'll make your wishes come true. Thank you.